I remain my humble self, Mr. Doramola AP, your honorable mathematics teacher. Alright, our class rules remain the same. Follow suit. The quote of the day, we have, if people do not believe that mathematics is simple, it is only because they do not realize how complicated life is, by Plato. And the topic before us today is finding area and perimeter of triangle, parallelogram and trapezium. In our last class, we've been able to find area and perimeter of square and rectangle, an equally composite rectangle. Okay, how do we find the area of this shape below? This is a scaling triangle. Alright, good. Our starter, we have to find the perimeter of this shape. Who can define a perimeter for me? I believe we are all finding and saying something. Okay, the perimeter of this shape is to add up all the three sides. 5 plus 15, 5 plus 12 plus 13. That will give us what? 25 plus 30 plus 5, which is 30. Alright. The formula to find area of a triangle is half base times height. The height is the perpendicular height. The way you stand is called perpendicular. You are standing vertically, perpendicularly. There are some heights that are in slanting form, but we are referring to the perpendicular height here. Area of parallelogram is base times perpendicular height, and area of trapezium is half into the sum of the two parallel sides times the perpendicular height. Okay, recall that perimeter is always the distance around the outer part of a shape. Okay, how do we find the area of this triangle? The triangle has been completed to form a rectangle. Alright, and the area of the rectangle is 5 times 12, which is 60. And looking at that shape very well, if you divide it into two equal parts, it will form a triangle. So 60 divided by 2 gives 30. If you look at this, this is slightly more complicated. I showed you this diagram from the previous slide. We have 8 centimeters as the base and the perpendicular height is 3. So therefore, the area of the rectangle, entire rectangle formed with it, is 8 times 3, which is 24. When you divide 24 by 2, you get 12. Let's take a look at this parallelogram. When you cut out this, you have this, and the original shape is 7 as the base and 3 as the perpendicular height. Alright, so the area is 7 times 3. Okay, this is a trapezium. Recall, the area of a trapezium is half into the sum of the two parallel sides times the height, and the parallel lines here happen to be 4 meter and 9 meter. Then the perpendicular height is 5, but it can be solved in two ways. Let's take a look. If you find the area of the first triangle, you have 5. The area of the rectangle, you have 20. The area of the third shape, which is triangle, you have 7.5. Then you sum the three of them, you will get 32.5 centimeters. And when you use the formula directly, you get the same answer. Right. Okay, let's take a look and watch this video. Sit back and enjoy yourself.
We'll look at the area of triangles, area of parallelograms, and area of trapezium. Let's look at triangles first. This is the easiest type of area of triangle question because you've got a right angle in the corner. Now, a right angle creates a line that is perpendicular to the baseline. So it's at 90 degrees. And these are the parameters that are needed to work out the area of a triangle. So the working is as follows. You take the base length, which is 6, you times it by the perpendicular height, the 90 degree height, so in this case it's 7, and you must remember to halve your answer. 6 sevens are 42, half of that is 21. And don't forget your units, centimetres squared. In this next example, we don't have a right angle triangle. We've got what looks like an isosceles triangle. We've got a base length of 8 metres, and then we've got two side lengths of 10, but those are not perpendicular heights. We want the 90-degree height to the baseline. So this is the perpendicular height that we're interested in. The calculation for the area would now be as follows. It's the base length of 8, we times it by the perpendicular height, which is 9, and then half our answer. And that would give us 36, and in this case, metres squared. In this final example, we have a base length of 18 and a perpendicular height of 12, which means that we can ignore the other two measurements. They're not required. So the area is 18 times 12, then halve your answer, giving us a final answer of 108 metres squared. We're now looking at area of parallelograms. A parallelogram is a quadrilateral with two pairs of parallel sides. There's one pair, and the other pair are there. So I've got two pairs of parallel sides. So when we come to work out the area, we would be tempted to multiply the base length of 5 by the length of the other side. But that would be slightly wrong, because what we want, once again, is the perpendicular height. So in this case, if the perpendicular height was 6 centimetres, then the overall area would be 5 times 6. Now, we don't have to halve this answer, so that would give us a final answer of 30 centimetres squared. Now, we've reached the final stage of this video, and we're looking at the area of a trapezium. A trapezium is a quadrilateral with one pair of parallel sides. Now, in order to work out the area of this particular trapezium, we must do the following. We must add together the length of the two parallel sides. Then we must always ignore the length of any slanting side. We would now measure the perpendicular height. So in this case it was 10 metres, and we would times that 10 with the length of the parallel sides that we've already added. Now there's one final thing to do. Just like the triangle, we have to halve our answer. This gives us an overall area of 100 metres squared. Finally, just as we leave looking at the area of a trapezium, sometimes a trapezium can be drawn like that, and we spot the parallel sides, leaving us just the perpendicular height to spot. So when this happens, don't be afraid to turn your page round, and you can now spot the perpendicular height, because that is at 90 degrees to the baseline and its corresponding parallel side.
Alright, let's move on. Okay, so the task before us is to work out the area and perimeter of the shapes below. Question 1, question 2, and question 3. Alright, I look forward to your response. These same questions will still be posted on the Edmodo platform. Make sure you work out your solution and keep it, so that by the time you are being assessed on this, you'll be able to give the correct answer. Our plenary, I believe we can now calculate the area and perimeter of the following shapes: triangle, parallelogram, and trapezium. Alright, what is next? We'll be learning how to calculate the area and perimeter of rhombus, kite, and circle. The lesson is prepared by Mr. Daramala APS from Mano College, reference to YouTube and test.